Energy is joules. The SI unit of work or energy, equal to the work done by a force of 1 Newton when its point of application moves 1 meter in the direction of action of the force, equivalent to 1/3600th of a watt-hour. What's is joules per second? The SI unit of power, equivalent to 1 joule per second, corresponding to the rate of consumption of energy in an electric circuit where the potential difference is 1 volt and the current 1 ampere. Voltage is electromotive force, EMF. A difference in potential, coulombs of charge, C, measured in volts, V, that tends to give rise to an electric current. Ampere is moving charge. Is the SI unit of electric current, I. The ampere is equivalent to 1 coulomb, roughly 6.241 times 10 to the 18 times the elementary charge, per second. 1 ampere equals a huge number of electrons per second. Electromagnetic induction. The induction of an electromotive force by the motion of a conductor across a magnetic field or by a change in magnetic flux in a magnetic field. Lenz's law. The principle that the direction of the current induced in a circuit by a changing magnetic field is such that the magnetic field produced by this current will oppose the original field. Equal, less losses, and opposite. Today, electromagnetic induction is entirely symmetrical. 1 input, 1 output. Newton's laws of motion. For every action, there is an equal, and opposite, reaction. A symmetrical system. Ensuring, there can only ever be an equal and opposite transformation of energy, less losses. A below unity system.
We last time talked about conservation principles, conservation of energy, of momentum, angular momentum, and so on. Now we're talking about symmetry laws. It's extremely interesting that there seems to be a deep connection between the conservation laws and the symmetry laws. This connection has its proper interpretation, at least as we understand it today, only in the knowledge of quantum mechanics. Now I would like to say, as we go on about other symmetries, that there are a few problems, new problems. For instance, for every particle, like an electron, there's an antiparticle, a positron. For a proton, there's an antiproton. And we can make in principle, what we call antimatter, in which every atom has its corresponding anti-pieces put together. For example, a hydrogen atom is a proton and an electron. If we take an antiproton, which is electrically negative, and a positron and put them together, they will also make a kind of hydrogen atom, an anti-hydrogen atom, in principle. It's never been made in fact, but this is figured out that we could make this. And so we could make all kinds of antimatter in the same manner. Now the question is whether the matter works the same as the antimatter. And as far as we know, it does. And one of the laws of symmetry is that if we make stuff out of antimatter, it'll behave the same way as we make the corresponding stuff out of matter. Of course, if they come together, they annihilate, there are big sparks and everything else. And it was believed that this is true, that matter and antimatter have the same laws. Now the next question is this. Once it's found that the left and right is wrong, the left and right symmetry is wrong, an important question comes. If I look at this integration but with antimatter, an anti-neutron goes into an anti-proton plus an anti-electron, that's an positron, plus a neutrino, the question is the antimatter behave like the matter in the sense that it comes out left-hand thread, or does it behave the other way? And it turns out, we think up until a few months ago, that it behaves the opposite way, and that the antimatter behaves like it goes to the right, where matter goes to the left. What it means that nature is 99.99 indistinguishable right from left, but that there's just one little piece, one little characteristic phenomenon which is completely different in the sense that it's absolutely lopsided, is a mystery that no one has the slightest idea about yet. Thank you.
Broken symmetry, or an asymmetrical system, where Newton's laws of motion extend to action, reaction and counterreaction. Electromagnetic systems that break symmetry, or asymmetrical systems, can be built, creating open systems. An example of asymmetrical systems. 1 input coil, two output coils, in magnetic resonance, where each current is 180 degrees out of phase, opposing. This system is an example of action, reaction and counterreaction. The Mr. Prevost experiment, shown in the first video in this series, is the first step forward in the learning phase to understand Don Smith's work. Some of these systems exhibit 1/4 wavelength, and may need to be grounded. Many other heroes exist throughout history,